The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
All right, so let's get started. My name is Jeff Probst, and today we're going to be talking about the essential tools of the command line ninja. I work at a company called Firehost Inc. I'm a Linux support engineer there, and I get to put these tools that I'm about to share with you today into practice every single day. So, as our guiding influence today, we're going to look to one of the best ninjas ever. His name is Ryu Hayabusa. Any of you who have played Ninja Gaiden, the more recent reboots of the series, may recognize this guy. He's pretty much the definition of a badass. So when Ryu Hayabusa gets on the command line, he has no troubles because he has all of his tools in place and he knows which ones to use for which situation. So we're going to try our best to be Ryu today. We're going to go over just a couple things. We're going to go into a fair amount of depth in each one. We're going to start with the Unix philosophy. Maybe you've heard the term Unix philosophy before. We're going to understand what that means. We're going to go through standard streams and redirection because those are among the more powerful things you can do. And then we're going to go straight from there into pipes and filters. And finally, we're going to cover all the tools. So the first three parts are kind of in order to understand the force part. Our goals here today. We're going to try and cover as much ground as possible. We probably won't be able to get through everything because this topic could easily take an entire day. To that end, I'd ask you guys to please hold your questions. If you can, write them down. We'll have time afterwards to discuss. If we start going through questions a lot, there's no way we'll make it through even half of this presentation. So please try to hold your questions to the end. And I will try my best not to confuse the hell out of everybody. So that's the agreement there. If you just can't possibly understand what's going on, go ahead and raise your hand, because you're probably not the only one in the audience that's confused as hell, and I don't want to lead us all astray. So, without further ado, let's head on in. The Unix philosophy states each tool should do one thing, and do that one thing very, very well. This means each tool focuses on one thing to excellence. So, let's say a good example of not doing Unix philosophy. Anything in the Microsoft Office suite. So Excel is actually a pretty good spreadsheet program. It also happens to have parts of Word and graphical utilities, and it's even got some PowerPoint bits, lots of printy bits, and just it's like, oh look, here's a kitchen sink over here, let's pull that in. Here's another kitchen sink. That is the exact opposite of Unix philosophy, excuse me. So we're looking for tools that do just the one thing. So if we stick with this Excel example, we want something that does just spreadsheets. Just spreadsheets, that's it. Shouldn't require interactive operation. So I should be able to run this tool without sitting at my screen. And every program acts as a filter, meaning it takes input of some kind, it does some useful, meaningful work, and then prints it out the other end. What you do with it on the other end, it doesn't care about. To do this, it's going to use the standard streams. Every process has 3 standard streams by default. You've probably heard these terms before. First one is standard input, the textual input data that you're putting into the program that you want useful work done on, which gets printed to standard out. Whatever work is done that's useful gets printed to standard out. Again, it doesn't care what happens after it gets printed. It just says, here you go, here's your data. And then for errors, you have the standard error stream. Anything that doesn't belong in standard out, or something it wasn't quite expecting, or anything out of the ordinary, would get printed to standard error. It's also common for programs to print help information. So if you invoke grep-h or something like that, then it's going to print its help information to standard error. That's pretty common. So using these 3 standard streams, we're going to learn about redirection. You can redirect these streams to and from files or into other processes. An example here, using standard N, we are redirecting the access log through a tool called grep. If you're not familiar with that, we'll cover it later. Here we're redirecting access log through grep, looking for this string of IP. In this case, standard out, we're redirecting the output of LSOF into a file so we can look at it later, denoted by this right caret. And here, standard error, we're redirecting the standard error output to yet another file, so we can look at it later. strace is a program which prints its output to standard error. The reason being, it's made to run kind of outside of a program. So the program will normally print its output to standard out, and standard error will have its own output on a second string. This is one of the rare few tools that actually breaks the paradigm and works okay. You just have to know that that's what it's doing. So here you note, we are distinguishing between standard out and standard error by the lack of or visibility of a number before the right caret. You'll notice also before standard in, there is no number. So those, both standard in and standard out, those are assumed. You could be a little more specific. You could put a 0 in front of the left caret there. You could put a 1 in front of the right caret in standard out, and it would be just fine. And if you go a little more advanced into redirection, which we will not do today, you may have more streams that you've defined. You would redirect those by putting the number of the stream in front of the caret and telling it where to go. The reason we have to use the 2 in standard error, because if you don't, it'll assume you mean standard out. In general, you're only going to be using these 3 types of redirection. It's rare that you'll have another stream that you're playing with. There are times. We're not going to cover those examples. But I encourage you to go look up and see the depth of what Bash can do with its redirection. It can do some really cool things. So, you can also redirect one stream to the current location of another. This is pretty commonly used. An example like this. Oops, there we go. So here in this example, I am using the grep tool looking for a certain string in a file. And now I don't really care what the output is. I'm just looking for success or failure. So I am redirecting all output to the bit bucket, which is /dev/null. Everything gets written to this file, gets thrown away. I'm also throwing all of standard error to the same exact place. So I am redirecting with this 2 right caret &1, saying send everything that the second stream, it says send everything from the second stream to where the place of the first stream is going. Now there's an important distinction here. It's not saying send it to the first stream. It's saying send it to wherever the first stream is going. There we go. There's a gotcha. If you flip the order of those 2 directives at the end of your command, this will not do what you expect. In this case, because we're redirecting standard error first, standard output is currently printing to our screen. So putting this 2 right caret &1 will redirect standard error to standard out, meaning it will print out on the command line. And then it will redirect standard out to dev null. This is probably not what you mean. You probably wanted both of them to go to the bit bucket. You don't care. But because you flip the orders of these things, you're going to have a bad time. So you may be expecting no output to show, and because you flip the order, suddenly you're getting output and scarbling all of your script up. It happens. So now that we understand a little bit about redirection, we can understand what a pipe is. When we want to redirect the standard out of one program to the standard in of another, we use a pipe, like this. So literally, it's just the pipe symbol. It's right above your enter key. You'll get to know it, use it, and love it. It allows us to chain commands together and create useful filters. And you can do this as many times as you want. Now, an interesting thing about this is each time you use a pipe, you're basically summoning a second command, or a separate command. There's going to be possibly one or many subshells involved in this. It could be a little bit inefficient, but the benefits of what you can do with your filters here far outweigh the inefficiencies that you may run into. So we're going to make an assumption that our tools can be used as filters. A well-heeled command line tool can be used as a filter. This means it accepts its input from standard in, or it accepts a list of files as arguments, which it then casts together and uses as its input, either one. It then does its useful work, prints it to standard out, unless you tell it otherwise, and it prints its errors to standard error. If a program acts this way, this is the standard way in which it acts, we can do lots of useful work with the tools we just looked at. If it starts deviating from that, then we're going to have to do some custom stuff, and it gets a little annoying. So our filter, all our programs that we consider as filters should behave this way. And if you're writing tools that you want to operate as filters, or you're writing little one-liners that act as inline filters, they should all adhere to this standard right here. So here's an example of something that's been filtered a couple times. I'm looking through an access log. For every instance, every line that has the word index.php in it, I'm filtering it through awk, looking for a certain return code, and then I'm using a tool called xargs to run another command on top of that. We're going to go through what all these mean here in a little bit. If this doesn't make any sense to you now, it will by the end of this presentation. So here, I forgot I did this. Yeah, we're feeding the output of grep into awk. Awk does its useful work. It's the last in the chain. Perfect. So now we're going to go into a section, or now that we understand all those basics, we're actually going to go in and start diving in on these tools. And the easiest way to do that is to go use them. So let's start with the single most important tool to the command line ninja, the one I use all the dadgum time. Screen. What does screen do? So I have something that's running for a long time. Let's say this script is going to take 100 seconds to run. I want to be working on this while I'm going, but the only way for me to do that is to do either job control, so now that's running in the background, or I can use a much better tool called screen. Yeah, that didn't do what I was expecting. Interesting. Okay, so let's try this again. Screen. What screen is doing is it creates a, I guess a holding process is a good way to put it. Inside of screen, you're running one or more bash sessions, or if you're not using bash for your shell, whatever shell you're using, one or more shell sessions. So by default, you get the first. So if you just run the command screen, you've done nothing. You've gained nothing. But where it really comes into play is when you're able to have 2 or 3 or 4 or 5 bash sessions all in parallel inside the same screen. So let's go back and do that little script I was doing again. Okay, so this is going to take its 100 seconds. I don't feel like waiting. I'm going to hit the screen control character, which is Control A, and I'm going to create a new screen session. This one's still running in the background, doing everything it's expecting to do. It's still printing to its buffers. Screen is handling all that for me. But meanwhile, over here, I can go and look at whatever I need to do. Oops, I don't have that installed. Okay. So I can do my work over here. Meanwhile, this script is still running back here, uninterrupted. I can look at the contents of this file here. And I can start up another session. I can do the man page on rsync. And here we go. I've now got 3 shells all running inside the same window. And I can use them in parallel. I can have a man page in one. I can be doing useful work in another. And you start using this really heavily, you find that, wow, I've got too many shells to manage. So there's a couple things you can do here. Using screen and the, oh, you know, I better show you this. That's not what I wanted. There we go. This is the screen command help page. There's a couple things of note here. When you want to create a new, well, I don't even list that one. Okay, here we go. At the top, you see the command key. This up caret A, that indicates we're doing a Control A. That's your command character. Screen is constantly looking at all of your keystrokes coming in, looking for this command key, Control A. And you can change that if you like, if it's not comfortable for you to do that. Some people like using a tilde. Some people like using some other command key that doesn't require a finger stretch. It's up to you. Just keep in mind if you replace something else with it, then like say you replace Control Z, I've seen this before. Then whenever you're madly trying to terminate a program because it's going haywire and you're hitting Control Z, well, you're just interacting with screen instead. So if you want to send a Control A, a literal Control A that has instructions right here at the top, it says Command key, Control A, literal Control A, you just follow it with an A. So that can get a little confusing, especially when you're panicking over something. Choose your command key wisely, because in the middle of the heat of battle, you're not going to remember that you did this. So let's look at some of the things that screen can do. Screen keeps track of all of our windows here. I did a Control A followed by double quote key. And this shows me all the windows that I have open. Not terribly useful right now. We can fix this. What's on Windows 0? We can't tell right now. What's on Windows 1 or Windows 2? We don't know. We can give those things names like this. This is my 1 to 100 script. Okay, that's a little more useful. This is my rsyncd.conf window. And this one is my man page. So now when I'm trying to find a window, I can find it a lot easier. So screen is keeping track of all these individually and letting me multiplex back and forth. And it allows you to work very highly in parallel. You can keep your main page up in one, you can look at something else in another. You don't have to open multiple SSH sessions to the remote server. That's the big win for me. Another big win is this right here. I'm doing useful work. Let's go back and do this script again. This script is running. In fact, let's make it go even longer. Terribly, terribly useful script. We know this is going to take a long time. This is going to take nearly 10 minutes to run. I don't want to wait on this. I have to go to the bathroom. I have to disconnect my machine. In a normal setting, I have to wait for this to be done before I can disconnect my terminal. And screen, I just detached from it. Screen is still running. That script is still running. Everything is working exactly as it is now and will continue until it's completed. All those bash shells are still going. I could pick up my laptop, walk away, go to a completely different network, log back in, reattach to screen. There's my script. It's a really powerful tool. I use this a lot. I have one of my VPSs has a running IRSSI session. So even when I'm not there, I'm still connected to IRC. It means that I have a really, really good level in my idle RPG character. It's easy. But whenever I want to log into IRC, I just log into that server, I reattach to my screen session, bam, there's everything that I was working on before. This is a terribly useful tool. I mean, this is probably the single most useful tool in your arsenal. If you aren't already using it, I highly encourage you to integrate it into your workflow. And it's really simple to understand, too. There's some things that we can change to make screen's behavior a little bit better. One of the problems it has is scroll back. So I'm going to terminate that script. We know that this is in printing a string of numbers starting at 0. I want to go back and see what that is. Well, I can't. Because in its default form, screen is only keeping track of exactly what is on the visible window. So that means when you're working within a screen window, let's say you're used to being able to scroll up and seeing what's in your history. You're not going to have that benefit anymore. You're going to have to start learning to use less, a lot more. So let's do something that takes, what is that? Whatever it is, let's look at it. Okay. So you have to get used to piping items through less or more, or whatever pager you like, which will let you do a pager within the size of your window, and being able to work in another window. So previously, where let's say you printed out some long command, and it's in your scroll back buffer, you'd scroll back your terminal up and you'd go check it out. Now, you're going to pipe it to a pager, and then you're going to open up another shell inside screen and do your work there. It's more or less the same thing. It's just something you have to be aware of. There is something you can do to fix this. Oh, I can't remember how to do this. I believe that's the command. What this is going to do is it's going to tell, oh, no, there's one more thing. We're going to tell screen we want to keep a scroll back of, say, 10,000 lines. Should be enough for what we're trying to do. So the first thing here is saying, screen, I want you to keep far more than what you're keeping now. I want you to keep 10,000 lines in your scrollback buffer. And the second item here says, understand when I'm giving you a page up and a page down, I actually want to go back and forward in my scrollback buffer. This is kind of a halfway solution to making screen work. So I'm actually going to have to drop out of screen to prove that this works. By the way, another thing here, screen will continue operating until you close every single shell inside of it. And if you forget that, then you start closing the shells where you had useful work. It gets really annoying. Another interesting thing about screen, before I go and talk about the scrollback, let's check out our bash history. Well, I was doing a lot of weird stuff. Here we go. So all the stuff we were doing in all these different windows kind of gets jumbled together because the bash is not printing its results to the history file until after it shuts down. So I could be working in one screen for 4 hours. I create a second screen, I do some useful work, I shut it down and go back to the first screen again. The second screen's history gets copied into the bash history file. Then when I close the first bash prompt down, then all that history gets written to, and it's going to be out of order. So it's something you got to be aware of if you're relying on your history file to get things done. You're going to have to keep in mind that things may be out of order. Okay, that admonishment out of the way. Let's now look at what it looks like. Let's do this also. Whoops, apparently I did that wrong. Ah, yes. There we go. So now if I have something extraordinarily long, I know we're taking on this little script. Okay, so now, remember before when I scrolled up, I couldn't see all the numbers before? Now here they are. I'm scrolling up in my screen and the scrollback buffer is present. Now there's something interesting here. When I go to another window, it will overwrite what's in the screen, scrollback buffer. Screen is still a little bit touch and go on the scrollback thing. So if I have yet another one here, so now this one lets me scroll back and check everything out here. Now you can see the scroll back has the contents of the other one, the first screen, it kind of mixed them all together. And what happens if I go back to the first screen again? What does it do? It overwrote. It's not keeping a scrollback buffer for each individual window that you're working on. It's got a global scrollback buffer. It's a little hard to understand. I think that's just a limitation of screen. Maybe if one of you guys are good developers, you could take a crack at fixing that. I would love you forever, but it's not a deal breaker for me. So screen. Screen is the single most important tool in your arsenal as a command line ninja. grep, probably the, how's it called, the Swiss Army knife of the command line? Yes, grep does many, many, many nice things. Grep lets you look in textual files or even binary files for certain key phrases or single phrases or whatever you like. So let's go, I need something of ample length. Yeah, you're probably long enough. So I'm going to grep this Etsy profile file for anything that says bash. So I'm invoking it as grep, and then what I want to be looking for, the string, and then the file to look into it. There we go. So every single line in the file that says the word bash has been printed out. We can make this a little more useful though by adding some options. What happens if I accidentally put a capital in there? Doesn't find anything because grep is doing a case-sensitive search by default. That's not always what you want. In fact, I typically run grep in this form. I add a -i saying make it insensitive. I don't care if it's capital or lowercase, find me that string. And there's all your strings. Another thing that's very, very useful. Okay, so now I know that bash is in this file. I don't know where in this file it is. So another very useful command line option is the in option. And this is going to print out line numbers for us. So now, not only can you find what's in your file quickly, and you can do it case sensitive or insensitive, you can print out the line where it is. So when you're trying to find information really fast, this is amazing. And I can look in more than one file. Let's see every single file here in Etsy that's got the word bash in it. So this is going to look at every single file in the Etsy directory. Oh look, I don't have permission for some of those. Every single line of every single file in the directory that I've specified that has the word bash in it. So you can see how rapidly you can find information in tons and loads of loads and loads of text files. I need to find all the information about one single IP in an access log. There you go, use grep. I need to find which of these dadgum files in this program, this entire module that's been written, is the one that's making an invocation to this library. Well, use grep. We can go even farther. We can do things like this. Remember, I was talking about programs acting as filters earlier. grep is a well-behaved filter. So we're going to pipe the contents of profile. I'm sorry, no, we're going to use the standard input redirection here. And it will give us the same results. Just like that. So grep behaves very well. We saw the examples of we can pipe, we can put our input in through standard in here. We can give it as an argument. We can give it multiple command line or multiple files on the command line. And it prints all of its results to standard out. Now we saw earlier something, and I want to go back and revisit. When you are scripting and you're using grep, sometimes you will run into situations where you don't have the permissions to look at a file. grep, being a well-behaved filter, will print that information to standard error. But if it ends up in the middle of your script, it may totally garf things up. So let's go back, what was that? Where was it? Here. So you see right here, oops, that wasn't good. Where did it go? Yes. I don't know if you guys, no, you can't see that highlight at all. I apologize for that. So the bottom third there, where it's saying permission denied, permission denied, permission denied, all that is printed to standard error. And if you're expecting items from grep in your script output and you're getting these permission denied lines, they're going to have a bad time. So let's use our redirection that we talked about earlier and get rid of that crap. There we go, gone. What we have done is we have redirected just standard error into the bit bucket. We don't care what that is. We only care about successful hits. Now, if you wanted to look at only the ones that were giving you an error, this would be one inefficient way to do so. There you go. All the files that we had permission or an error with. Okay. So grep, very powerful tool. And you can do cool things like recursive grep. There's a whole lot of files in this directory. It just goes forever. I don't know where in this directory the item I'm looking for is, but I know that it's somewhere in here. So let's go look at all the files. I'm going to give a recursive flag. Dash, I don't know if it's capital or lowercase. I've always used capital. I don't think it matters. Recursively search every single file in this path for anything, any file that has, let me make that at the top, that's easier to say. Recursively search every single file in this path for that string. Throw everything that's being printed as standard error to the bit bucket, we don't care. The useful information we do care, put it through a pager called less. And this could take a short amount of time. Now here's an interesting thing that grep is doing. It's actually looking through binary files for strings. It won't print out the binary matches because it's kind of ugly. And there will be times where grep thinks the file you're looking at is a binary file when it's really not. You can force it to go ahead and print that. That's a flag. I have to look at the man page for it because I use it so rarely. But it's being a good guy here. It's saying, hey, I found a match in this binary file. I'm just not going to print it for you because it looks like somebody barfed on the keyboard. But here we see all the way right here, starting in the Etsy app armor line. We told it everything inside this Etsy directory, and it found this 3 levels deep. So when you've got to find something, grep is your tool. It's amazing what it can do. You'll use it everywhere. This was an example I alluded to earlier. There are a ton of running processes right now. I only care about one. So here we see all of my bash shells. I have 2 bash shells running in screen. Amazingly, I show 2 bash processes running here. Now you'll also notice, I don't know if you could see it. Wow, you really can't see it at all. Look at that. This coloring is horrible. I apologize for that. One of the things that has popped up in more recent modern times is coloration on your console. By default, I think the Debian-based distros and even Red Hat-based distros will do this, where it's giving color for the items that we find. And that actually says bash. I don't know if you can see that. Yes, sir. I actually kind of like the color. Okay, for the presentation, okay. It is. Clever guy. Okay, let's try that. Hey, look, there it goes. Excellent. All right, so now you guys can actually see what I'm talking about. So, that's a more recent advancement. Some of you may like color, some of you may not. I personally prefer having color on my console. It gives me context clues that I can get in quickly, whereas I may have to look at them. For example, here, this is giving me context clues on what's directories and what's not. Without color, you'd have to actually do an ls-o and then grep and look for anything that starts with a directory. There you go. Oh, by the way, I didn't mention that. Regular expressions. We're not going to cover that at all. I think there was a class in that already. Okay, so hopefully you attended the regular expressions class, or you already know them, or you can go check them out later. grep understands and speaks regular expressions, but you have to put it into, let me clarify here. grep understands regular expressions, but 9 times out of 10, the way you're going to want to use it, you're going to want to use it with extended regular expressions, like that. So whenever you use regular expressions in grep, just add this -e option. Just get used to it. That's what you're going to need to do. But grep does speak and understand regular expressions. In fact, that's how it's commonly used. Again, I'm not going over regular expressions because that can take hours. I encourage you, if you don't understand what they are or you're a little bit shaky on them, go through a regular expressions tutorial. Anything like that, just please don't ask me because I don't like teaching on that. Sorry, I'm just being honest. All right, so that's grep. awk. This one is not used as much. I don't know why. This one is a really powerful one. So what does awk do special? Awk is kind of like grep. You could also say grep is kind of like awk. They're looking for useful information in textual files. The difference here is that grep doesn't care what the input text is. awk is looking for regularized data. It's looking for things divided up into columns. And what do I mean by that? Okay, let's look at this. This is data divided up in columns. It's separated by spaces. Let's say come on. Let's say I only want to look at, I only want to get the UID. I want to find everything. Let's do this. Let's use the tools we've already learned about. I want to look for everything that's running a bash shell, and I only want to print out the first column of this. If I wanted to do this with grep, it'd be very difficult. I'd have to, actually I don't think I could do that with grep. grep is just doing a match on certain individual files, or certain individual lines. There are other tools that can do this. awk is the most well suited. awk says, I understand this data comes in columns. By default, awk assumes one or more spaces in a row is a column separator, which is perfect for us here. So I want to print out the very first column. So that's every single user that has a bash, anything with the word bash in it, in the process name. I've printed out just the first column. I can do more than that. I can print out the first 1, 2, 3, 4, 5, 6, 7, 8, and first and 8th column. So there you go. There's the user and what the process name is. I'm able to pull very useful information out of columnar data. So this is terribly useful when you're doing some more advanced stuff with, say, your access logs from Apache, which comes in tabular format and comes with way more information than you usually need. Let's see, I think I have some of those laying around somewhere. Actually, I don't think I have any on this system. Let's just keep picking on PS. So I can do some cool things like, all right, so we have this field in here, S time, start time. You have a question?
I was going to say you can also use a comma instead of putting like a space in quotes.
Okay, that's good to know. That's good to know. So he's suggesting that using my example here, let's move that to the top of the screen. Here I'm printing out 2 columns. I'm printing out the first column and then the 8th column, and I spaced it out with this right here. He's saying that I could also do this. Oops. And that would accomplish the same thing, correct? Okay, so let's try that. Exactly. So awk is a little miniature programming language. It's not a full-fledged programming language. It's tailored for doing the few things that it wants to do and doing those very well. Again, it adheres to the Unix philosophy. So we're not going to have time to go into everything that awk can do because it is a scripting tool. But you can get some pretty complicated stuff like, here, I'll show you an example. 2, 3, 4, 5. Another thing to note that I do not like about awk starts its column counting from 1. I never liked that. But it does that because if you want to print the entire line, you can print out 0. So in this form, awk is doing nothing useful at all. I can take that off and get the exact same output. Oops, there we go. So look, I get the exact same output. But I do this to illustrate that when you're printing this $0, that says the entire line. If I want just one column, there we go, just the one column. Now I was about to show you a more complex example of what awk can do. 1, 2, 3, 5. This 5th column is the start time. Let's do something like this. Oops, I gotta do this. If I can remember how to do this. I am drawing a blank. So what I'm trying to demonstrate here is that awk allows me to throw all this data into an array. The guy over there that's done a lot of awk, can you remember how to tell me how to get through, iterate over an array? I can't remember how to do this off the top of my head.
I don't remember.
Yeah.
I think you might need parentheses, I'm not sure.
So I'm trying to do something like this. This is the wrong language that I'm mixing in. Let's just see what happens. Like that. That's effectively what I'm trying to do. And it's going to complain. Yeah, okay, so it doesn't understand that. What I'm trying to demonstrate here, I'm looking at the contents of PS. I'm pulling out just the 5th column. I am saying every time I've got, say, 08:52. Come here. Every time I have, say, 08:52, increment that value in this array. So what ends up happening is I've got an array populated with every single S time value in the file and the number of times it shows up. And then at the end of the script, that's what this end in all capitals is doing here, go print the contents of this array out and show me how many times does each different instance of that column show up. Yes, sir?
For that, I usually pull off to pull out the column, sort unique dash C.
I'm sorry?
Unique dash C.
Is that what I'm doing wrong?
Sort, pull out your column, type it.
Okay. So he's suggesting that we can do this another way. We can pull out just the columns like this, and then pipe it to sort-c, which will give us a count. Oops, pipe. And again, because awk is a well-behaved function, acts like a filter, we can do cool stuff like this. Disorder. That's not what I was expecting. Let's just look at this. Okay, so here we've seen awk has trimmed its column out. Sort-c. Should give me a count of each line, right? That's what I'm expecting. Let's go look at this real quick.
Sort-L.
Yeah, okay, so we're looking for a count.
So your error before was in your for loop.
I'm sorry?
You're thinking of unique.
Oh, you did say unique. Unique.
Pipe, sort, pipe, unique dash C.
Okay, unique dash C, like this.
You're going to need to sort first, otherwise it won't be.
Right. Okay, so here we're illustrating one of the powerful parts of our command line in that we can pipe tools into other tools. We can do lots of cool stuff like this. Thank you guys for keeping me sorted. Excellent, that's exactly what I was hoping to do with awk. We weren't able to do it because I was not able to remember how, so we were able to do it with another way. This illustrates another point of bash. There's always more than one way to do it. You've heard?
I think your problem you did first was in awk. I think it was in your for loop. You should have been for I and dollar sign time.
Okay.
You're just for I and time.
No, I don't think you need a dollar sign in front of the I at all. I got it to work, but it looked weird.
Oh,
Printed stuff.
okay. Excellent. Share it with me later so I can remember how to do it. There's so many tools here. This is one of the problems, actually. There's so many tools and so many different invocations, and awk being its own scripting language with its own syntax, I can't remember all of it. If you can, more power to you. I can't. So that's why I use Google as an extension of my memory. I can't remember how to do a loop. Okay, I'll just go to Google and look for it, you know? I don't know, whatever. I'm not going to do that here. But awk is a really powerful tool if you've got your data in columnar format, which a lot of data is, and you can use it to do cool things. Another tool we're going to go over, let's see what's next in our list. Find and xargs. Whoops. So find lets you do some really cool tools, like really cool things. I want to find everything that's changed in the last 4 hours. Let's go here. I'm going to find everything in this current directory, that's what the period is. You always have to give it a directory place. Find everything that has changed in the last 4 hours. The only thing that's changed is my less history. Okay? Let's try everything that's changed in the last 1 day. Okay, a couple things have changed in the last day. Everything that's changed older than 1 day. Okay, a whole bunch of stuff. So find lets you look through all the files in whatever directory you specify, looking for certain key components. And you can chain things together, like I want to find everything in this directory that's been modified in the last day, if I could type. Everything that's modified in the last day that also has a name fragment of something like that. Oops, this one doesn't accept regular expressions. Let's try this. There we go. That's what I forgot. Wow, this is really working well. There we go. So I can combine multiple items, multiple, not flags, not the right word. Qualifiers is the word I would use. I'm combining multiple qualifiers into one find to come up with just a list of files that I care about. What can I do with this list of files? You can do something like pipe it as a list to tar to create a new archive. Oops, This is working so well. Should not have been drinking that much last night. Whoops, that's on the recording now. I can, let's say I want to find everything that's modified in the last day with the name of that. And I really need something, let's just try this. Listing everything in my home directory. I can pipe it through grep. Again, grep is a well-behaved filter. Thank you. Look for just files with a certain name. I can do things like, I can change the ownership of everything. And we'll talk about the Xargs tool shortly. Like this, which doesn't print anything, but what that just did is it took everything in this list and changed the ownership of those files to the user Jeff. Now I'm logged in as the user Jeff, so functionally I just did no change. But I just wanted to demonstrate that this could be done. So when you want to do useful work on find, either you use your filter tools that we've already talked about, or some ones we're not going to talk about. If you want to actually do some actions on these, I usually pair my find commands with this Xarg command. Find has a built-in way to do some way to run meaningful work. Let's say I wanted to do the same thing I did up here. I did this chown Jeff at the very top of your screen. I'm going to do it with the traditional find method of doing it. A little hokey, doesn't, wow, what am I missing? What am I? Oh, yes, thank you. So there we go. That's the traditional way of running find. Here I've specified the exec flag, and then it's going to treat everything after the exec until it gets to the end of this semicolon as the command it wants me to run. Now, one of the interesting things about find is it's a little inefficient. Canonically, find would run this command, chown Jeff, whatever, for every single line in find's return values. So this presents a problem because that's kind of inefficient. What if I do a find and I get results 10,000 files back? Why do I want to run the same command on 10,000 different times? That seems slightly inefficient. So I want to be able to bundle these together because I know I can do something like this. Let's see what we got here. I know I can run this one command on multiple files. It's a well-behaved program. I know this works. Unfortunately, find doesn't give me the option to do that, and that's where Xargs comes into play. Xargs takes a list, a vertical list, like this. This is a vertical list of information. Xargs changes it so it's horizontal. That's all it does. Very simple program. And if you give it the right, depending on how you use it, let's do this. So there, it converted that list of horizontal data into a list of vertical data. Now, it doesn't really mean anything because we have lots of spaces and such. But what does this allow us to do? It means that we can take a list of items that are organized horizontally, convert it vertically, and throw it through something else. I can do something like this. And I'm going to add a little special sauce to protect myself. So what am I doing here? I am printing the results of the find that we've been doing repeatedly. I am piping the contents of that through Xargs. This print 0 modifier means I want to print every single line that find is finding and putting a new line on the end of it. A null character at the end of it. And then I'm telling Xargs, look for null characters as your path separator. So Xarg is going to take this list, this vertical list, convert it to horizontal, and throw it through whatever command I tell it. So in this case, Xarg is going to take that vertical list, make it into horizontal using this null character as the separator, line separator, and run this command. It is intelligent enough to know how long can I make this command line invocation. I think it's 32,000 characters or something like this. When you have 10,000 files you're trying to run through, you'll easily max out 32,000 characters. Xargs is smart enough to know I can't put every single file on this one line and put it to my command. I have to break it up. So it goes up to some maximum file line size, runs that command, it goes and builds another line as long as need be, runs the command, and keeps doing this over and over again as efficiently as possible. So we're not running chown 10,000 times, we're running it 5 times as efficiently as possible. So whenever I use find, I usually pair it with xargs because I'm doing useful work on it. And again, both find and xargs are well-behaved programs. They adhere to all the things we've discussed earlier. So let's see, what else do we have?
When would you use -0?
When you have directories or files with spaces. Okay, let's do an example of that. Yeah, I love demonstrating this. Okay. Oops. Okay, so now I have one file with a space, one file without. When I do a find, it prints them out on lines. Let's do this. Well, is that what I want? -N1? Like this?
-N1 echo.
So there we go. Thank you very much. These people know more than I do. That's great. You should be up here. You want to come up here? Sorry. So in this case, xargs, we're giving a flag saying, go ahead and run this command every time we get a value. So we see xargs is splitting on spaces, tabs, and inlines as useful separators. Problem is, our file had a space in it. So xargs consider these 2 separate items, the A and the file. Well, that's all one file name. So if we do this instead, we're telling find to print with trailing new lines. We get exactly what we expect. It properly handles the space. So when you're pairing find and xargs, or find and anything really, but usually find and xargs, I prefer to use this print 0 option so it saves your ass when you've got directories or files with spaces in them. Just get in the habit of doing that, because if you don't and you run into a directory with a space and you're in the middle of a script and you're like, why is this not working? It's breaking. It's going halfway through and then it's breaking. Well, it's because you assumed that you had no directories or files with spaces in it. And that's not always a valid assumption. All right, our next tool on the list, Perl. Now this, again, could take hours and hours and hours. We're not going to go into Perl. We're just going to introduce a couple useful invocations for it. Namely, the Perl pie. Yes, thank you for reminding me yesterday. This man over here, Andrew, gave a very excellent talk on Perl, and he made sure that I would not to forget Perl pie. So, what is the Perl pie? Let's do this. I'm going to direct this to a file. Just to make this interesting, let's do that. So now I've got some data in a file. And what's in that? Okay, we got lots of repeated data. I want to change every instance of the word root to something else, because I want to give this to somebody else and I don't want them to know that I'm running all these processes as root. Just as an example. So I want to change everything in this file in place to monkey, because I like monkeys. Oops, I gotta give it the file. All right, so the Perl pie. This says we're gonna run Perl. And let's do this in reverse order. The -E says I'm going to give you a tiny little Perl script right here as a one-liner. So this right here, this again, we're not going too far into Perl. This is saying on every single line, do a search and replace, replacing the word root with the word monkey. The -P and the -I means in place, and P means something that I forget. Andrew, what does it mean?
It means that it does that is an expression on the line and prints it out?
Right. So it's going to treat everything that comes in. Again, Perl can behave as a well-behaved program. So everything that's thrown to it, input, in this case we're giving it an argument of a file name, it's going to treat it as a line of input and do whatever it is we've told it to do on every single line. So in this case we've told it to do this one-liner, this swap of the word root for the word monkey. So let's go look at that file. We should see, look, every time it says the word root, we've replaced it with the word monkey. We did this in place. There's other tools to do this with. Sed comes to mind. Sed will also do this. There we go. So now we've changed the word monkey into hippo using another tool. We're not going to go into sed. Sed is kind of in the same family as awk. Usually when you see an example of one, you'll see the other. We are going to go a little bit more into Perl because I find it a little bit more useful. How are we doing on time? Ooh, we're almost out of time. Yeah, so Perl's really cool, and who has questions? Questions, comments? Anything I was not clear on? Anything you'd like me to go over in 2.5 minutes? 2 minutes?
Show us a couple of your useful examples for Perl and command line, because I never used that.
Okay. I need some source data, which I don't have. Let's see what we can do with this. Okay. Oops. What just happened? Oh, the network just dropped. Okay.
Okay, there wasn't anything useful in Perl.
Thank you, Alan. Thank you very much. So it means my SSH session is just about to die, which means I'm no longer able to show you anything. I would love to. We'll do it after the class. Anybody have any other questions? Anything that doesn't require me to type? Yes, sir.
You said that xargs takes a line, but that's not the default.
Okay.
It actually takes words.
Words. Okay, that's a better way to put it. So he's saying that I misspoke. He said xargs takes words instead of lines. It's a better way to put it. Thank you.
If you want lines, you can do, I think, -L.
Okay. So I encourage you to look further into the man pages of all the tools we've introduced here and some of the other tools that we've not introduced. Maybe some of the stuff you saw flash up on the screen. These tools have lots of invocations and lots of useful options. We just don't have time to cover them all in a 1-hour session. Yes, sir?
One of the nice things about XArgs is if you have a ridiculously long list that you need to pipe through, XArgs will separate that memory from the shell, so you do not hit memory cap and kill your command out.
That's a good point. He's saying that, well, that was actually a mouthful. Can you say that again, please?
XArgs will separate out the memory that it's using for parsing out the lines, words, etc. So that you're not killing memory cap on your shell when trying to execute your set of pipe commands.
Okay, good point. So he's saying that if you're using xargs as opposed to your shell command, you're not using the RAM from the shell command, and if you have a RAM limit on what your shell can do, every time you run a pipe through, you're going to be using more and more RAM. xargs is actually a separate process, and so that RAM is not counted against the shell. Is that what you're saying? So that's another good benefit to it. Yes, sir?
I want to go back to screen and tell you that when you talk about the buffer, if you use a Control-A escape and page up, you can go back to it.
Oh, say that again? Oh, right. We lost my connection. Let's see if I can get it back.
Hit screen whenever you want.
Hey, restored! Excellent! Okay, so what am I doing here?
Screen, some scrolls off the screen,
Yeah?
so go ahead and do your for loop.
Okay.
CQ 100.
Okay.
An arrow or page up or anything like that will go into the Windows buffer.
Oh, that's how you do that. I never knew that. This is why I come to these conferences. Okay.
Paste as well, but I
Okay. It's a little clunky.
Left bracket.
Okay. Sir?
For XArg, you can actually run parallel tasks as well.
Okay. Even better.
For compressing large files.
Excellent. So xargs has many uses, more than just the one that I tend to use it for. So you guys are excellently smart. So collectively, we're teaching each other all these tools, little tips that we don't know about. Okay. Actually, unfortunately, we are out of time, so I'm going to have to close it down. Guys, thank you very much for coming. I really appreciate it. And if you have any other questions, I'll be up here for answering, and we'll come talk and share other tips and tools we have. Thank you very much for coming, guys.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and then fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You'll have dozens of data centers and thousands of servers in each data center. Hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and the administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication from Wicked.